Geometry Unit 14, Section 5, the area of sectors. So this is coming after arc length, which was section 14.4, and we had this formula here that's x over 362 pi r. And you knew that 2 pi r is the formula for circumference of a circle. And the x over 360 is just basically what fraction of the whole circle do we have is going to be what fraction of the circumference, and that's how we do arc length. You're going to see something very similar for area of a sector of a circle. So let's see where this comes from. Circle O has a radius of 10. What is the area of the circle? Well, to know this, we need to know the area formula of a circle is pi r squared. Another formula that's given to you, but shouldn't have to be. You should really know that one. So the area of a circle with a radius of 10 would be pi times 10 squared is 100 pi. And of course, I could type into my calculator 100 pi and get a decimal approximation for that. I'd have to round it since pi is an irrational number, but let's leave it as pi for now, and we'll see if we want to change that. But the reason we want to leave it pi for now is because it's going to be a lot easier working with that number than whatever that decimal happens to be. It's probably, well, let's see, pi is about 3.14. Times 100 is probably 314 point something, all the decimals that come after the 3.14. So just waiting for this to move off my screen. That's fine there. Oh, so let's just check that for the heck of it. 100 pi is 314.159, so on, so on. So if they wanted the answer to the nearest 10th, 100th, something like that. Circle radius of 10, the area is 100 pi because of pi r squared. What's the area of half that circle, or a semicircle? Well, if the whole circle is 100 pi, halving that is halving the area, so that'd be 100 pi cut in half is 50 pi. Well, what about a quarter of circle O? Well, a quarter is the same thing as a fourth of the circle. That's going to be our 100 pi divided by 4 is 25 pi. Well, how about the area of a sector of circle O? So circle O, still the same circle. The whole thing's 100 pi. Instead of half of it, instead of a quarter of it, let's do a section that's defined by a central angle of 60 degrees. And remember, a central angle of 60 degrees means that the arc is also 60 degrees. So how much is 60 degrees of the circle? Well, the way I can figure that out is I can say, all right, 60 degrees is how much of 360? 60 degrees is how much of 360? And the answer is, it is a sixth. So instead of doing half of my area, a quarter of my area, I need to do a sixth of my area of 100 pi. So a sixth of 100 pi. And a sixth of 100 pi, 100 divided by 6, I don't think that's going to really come out nice. I could just leave it 100 pi over 6. But let's see, I know that could certainly be reduced to probably 50 over 3. But let's see, 100 divided by 6 is, no, it's not a very nice decimal, so math double enter it, and it's 50 over 3. So 50 over 3 would be the simplified version of that answer. But think about what we did for all three of these examples, that if the whole circle is 100 pi, well, half of it would be a central angle of 180 degrees, would be 50 pi, because we did half of 100 pi. And a quarter of it would have a central angle of 90 degrees. That was a fourth of 100 pi. And a sector of 60 degrees with a central angle, well, that was 60 over 360 is a sixth of 100 pi. So instead of a half of 100 pi, a quarter of 100 pi, we have a sixth of 100 pi. But it's always how much of the circle. Do we have half the circle, a quarter of the circle, a sixth of the circle? And it was easy when it's half quarter, but for 60 degrees, we had to kind of figure that out using this, well, how much of 360 is it? And that's essentially what this formula is. And again, that's why it's so similar to the one for arc length. It's x over 360, just like you saw in the last video, x, how much of the circle times the circumference of the whole thing, or how much of the circle times the area of the whole thing. So is it half the circumference, a quarter of the circumference, a fifth of the circumference, half the area, quarter of the area, a fifth of the area. So it's the same general concept that we know we can do basic circumference of the whole thing, and then we can do a portion of that. just as we could do the area, basic area of a circle, the whole thing, and I could do a portion of that. So find the area of sector ABC. So that's this. They want the area of that slice. A slice of pizza cut into a pie. And actually, that's very relevant here because I think this is going to end up being an eighth. But you know, the area of a sector is exactly that. I know the area of the whole thing I could find very easily, but I just want that piece right there. And so the way to do that is the central angle is 45 degrees, so that means the arc is 45 degrees. So that's 45 out of 360. And you could simplify that. I mean, you could leave it 45 over 360 in your calculator, but what that does come out to be is an eighth. And so it's an eighth of the circle. And so an eighth of pi r squared. And with our radius being 12, that's an eighth of pi times 12 squared. And 12 squared is 144. So 144 pi. An eighth of 144 pi. 144 over 8 pi. And we want to simplify that. Not sure if 144 can be divided by 8. I know it can be divided. I'm going to say yes, but let's just check that. 144 divided by 8 is 18. Yeah, so you're good. So the answer, final answer here would be 18 pi. And of course, I could type that into my calculator and round it to the nearest, you know, tenth, hundredth, whatever we want to do. 18 pi. That'd be 18 times, you know, 3.14, so on, so on, so on. So just another quick example. What are the area of the sectors of AOB and COD? Well, for AOB, this piece right here, that's a 30-degree angle. So 30 is how much of 360 times pi r squared. And for AOB, my radius is 4, so that would be 4 squared. So again, you could just type that into your calculator as you see it. Don't type in the pi, though. Just type in the 30 over 360 in parentheses, and then you could do 4 squared, or you could change it right away to 16. But we want to leave our answer in terms of pi unless we see the directions say rounded to the nearest tens, hundred thousandths, 10,000ths kind of thing. But 30 out of 360, how much does 30 go into 360? I think that would be maybe a 12th, but I don't have to guess. 30 out of 360 is, math, double enter, a 12th. So it is 1/12 of 16 pi. So that's what 4 squared pi is. A 12th of 16 pi is 16 pi over 12, and that can certainly be reduced, divided both by 4. That's 4 pi over 3. And of course, again, if I want to make that, let's say 4 pi divided by 3 in my calculator, that comes out to be 4.2 if I want to round to the nearest tenth. Then how about the area of COD? All right, so it's still a 30 degrees, but this time we get a radius that goes from here to here. That's going to be a total of 6. So for COD, so let's say this is the AOB area. And over here, I'll do the area of COD. And let's just see, that's going to be it's still 1/12, or 30 over 360, whatever you prefer. It's still 30 degrees, but this time it's pi times 6 squared instead of 4 squared, and that would be 36. And 36 pi over 12 works out to be 2 pi, which is about 6.2-ish. But that's my area there, that's my area there. This question didn't want it, but if it wanted just the area of this little piece over here, like here, I could subtract those two areas. I could do 2 pi minus 4 pi over 3 to get that overlapping region kind of thing. See a question maybe go a little bit further like that. So it's basically pi r squared, but how much of the circle are we working with? A half, a quarter, a sixth, and we could figure that out by doing your arc angle over 360. And so if they give you the central angle, it's just that angle. But if they gave us, say, like an inscribed angle, well, that would kind of change things a little bit. We'd have to think a little bit more carefully about that. All right, so that's area of a sector. See ya.